Hello class, this is a continuation of Combinations Part 3. In this video, we'll be looking at proving these three identities. However, we won't be using any numerical values for it. It'll make it slightly more difficult, but if you understood these proofs pretty well, you'll see that it's not so difficult trying to understand these a little bit more. So, let's get straight to it. Using the definitions, let's just do this one first on the left hand side. It's kind of interesting because it's the exact same thing as this one here. So this left hand side is going to become n factorial over n minus r factorial n, not n, r factorial. Let's do the right hand side now. Now let's take a look very carefully at how I'm going to write this out. Take a look, n factorial, still the same. But now take a look at how I'm going to write this one here. So these two. Notice how it's n, the top, minus the bottom. So watch how I'm going to write it. Use a bigger bracket. The top value, let's use some color coding here. This top value minus, using the definition now, since it's r and r is on the bottom, we're going to minus everything in that bottom value there, that r value. So it's n minus r, like that. In the exact same way, since this is r factorial, well, we're just going to follow the definition to a T. We're going to follow it exactly as it is. So n minus r factorial. Hopefully that made sense. So remember, it's n, the one on top, minus r, the one on the bottom. Following that exactly as it is, n on top minus n minus r on the bottom times n minus r factorial. So let's keep going further with this. The numerator doesn't change. Expanding this now, n stays the same. Expanding this out, we get minus n plus r, because minus times minus becomes plus factorial n minus r factorial. Numerator doesn't seem to be changing anytime soon. Over n minus n is 0, leaving us with r. That's just r factorial, which we can just write as r factorial bracket n minus r factorial. But since this is multiplication, we can just switch these around, can't we? Which is exactly what I'm going to do. Let's switch them around like this, which is equivalent to that left hand side, and we've just proved it. So would you look at that? Let's try it again for this one here, using strictly just the definitions. N pick r, that's r factorial over n minus r factorial. If ever you keep forgetting, just remember this definition for the choose, and for pick or p, we remove that r, so it's just this. So that's the left hand side. Let's do it now for the right hand side. This right hand side is going to become r factorial times, using the definition of this, I'm just going to be a little bit lazy and just copy this one here, paste it there, and let's make it black just to make it look as if I wrote it in. Okay, there we go. So we're just following the definition of the choose, or a combination, sorry, Well, if you take a look, that's r times this division. If we were to write it out in full, it will become n factorial times r factorial over n minus r factorial times r factorial. That cancels out, leaving us with n factorial over n minus r factorial, which is equal to that left hand side, and we've proved it. Alright, so that's the first two proofs. This last one's actually, as you probably felt from this, it was rather long. So I'm going to leave this to one more video to show you the proof of this without using numerical values. So I hope to see you then. Best of luck.